This video is going to discuss how to graph quadratic equations when in standard form. Prior to graphing, it's important to know characteristics of a graph of a quadratic equation as well as basic vocabulary. A quadratic equation will graph as a parabola. It looks similar to a horseshoe shape or a U. It has an axis of symmetry, so if you had a coordinate grid and this was your parabola, in this case, the y-axis would actually also be the axis of symmetry because it splits the parabola in half and it could fold over itself. Each parabola also has one vertex. So when you have a quadratic equation, you will see the vertex. So in this case, I'm going to draw a parabola the other direction, and the vertex would be that very tip point or the maximum point of the parabola. If the coefficient a is positive, then the parabola is going to open upward, like this. But if the coefficient of a is negative, then the parabola is going to open downward, like that. So some people think if it's positive, it's a smiley face, and if it's negative, it's a frowny face. And just to remind you that a comes from the quadratic formula, ax squared plus bx plus c equals y. So there's your a that you're looking at to determine if it's positive or negative. Regarding the basic vocabulary, we have parabola, which we've already discussed. It's the graph of the quadratic equation, which makes a U shape or a horseshoe shape. The vertex, which is the highest maximum point on a graph or the lowest minimum point on the graph. The axis of symmetry, which is a vertical line that goes through the vertex of the graph, and the parabola is symmetrical across its axis. And then finally, standard form of quadratic equation as well as the vertex form of the quadratic equation. So now we're going to go over the basic process for graphing from a quadratic equation in standard form. So if y equals ax squared plus bx plus c, and your example is x squared plus 2x plus 2 equals y, the very first thing we're going to look is to determine if the graph is going to go up or if it's going to open downward. So looking at the value of a in the quadratic equation, if it is positive, it will open up. If it is negative, it's going to open downward. So when we look at that, our x squared is there. We don't see anything in front of that. But we could draw the number 1 in front because there's 1x squared. So the coefficient is 1. A has a value of 1. It's a positive 1. Then, since we know that and it's positive, we know that it's going to be a parabola that opens upward. It's our smiley face. The next thing we're going to do is we're going to find the axis of symmetry. So going back to our equation, and I'm going to put that 1 back in there because some people like to just see it visually and know that's the coefficient. So our axis of symmetry formula is negative b over 2 times a. Our b value is this second portion right here. It's our second term. And so the 2x2 is our b value, but it's going to be a negative 2 because we want negative b. So that's where we get the negative 2 right there. Then we go back and we find our a, which we talked about. It's 1, and we're going to place it right there into the equation. So negative 2 stays the same because there's nothing in the numerator to multiply it times. But in the denominator, we have 2 times 1, which equals 2. Then negative 2 divided by 2 equals negative 1, and so now we have our axis of symmetry. If you look down at the graph that is in step 4, you're going to see a purple line. That is your axis of symmetry because your axis of symmetry is actually the line x equals negative 1. So it's going to be a vertical line going through the negative 1. To find the vertex, remember the vertex is the minimum or maximum point of the parabola. And so it's the tip of your parabola. It's going to go through the axis of symmetry. So if we take x equals -1 and we substitute -1 into our original equation, x squared plus 2x plus 2, we're going to get our y value, which is going to give us our coordinate. So this is what I've done here in step 3. I've substituted the -1 in, so it's -1 squared. Notice that there's parentheses around that because the -1 is getting squared, not just the 1. Then we have plus 2 times -1 plus 2. So -1 times -1 is a positive 1. And 2 times -1 is -2. And then we still have the plus 2. So these are going to cancel themselves out, and you end up with your positive 1 for y, and therefore your vertex is -1, positive 1. And you can see us have that right there. And in the graph, you can see the dot down there as well. Okay, so we've graphed our axis of symmetry, we've graphed our vertex, and now we're going to go to step 4. Step 4 is going to have us actually create a coordinate grid table, an XY table, to help us find some more points on the parabola. We need to treat this the same way as we would with an X and Y table for a linear equation. So I'm just going to draw an X and Y table, and I already know that my axis of symmetry was the -1, but my vertex was -1, 1. So I'm going to place that in the middle, because think of symmetry. If that's the middle of everything, my axis of symmetry, my vertex, should go in the middle of my table. It helps me build off from there. So I'm going to choose 2 integers greater than the x value of my vertex. So my x value of my vertex was -1. So 2 values greater would be 0 and 1. Now I'm going to choose 2 integers less than my x value of the vertex. So -1 is my x value for the vertex. I'm going to go backwards 1 and backwards another 1. Now I just have to substitute each of those into the equation, and so you can see my work that I've completed here, right here and right here. So for 0, we see that y equals 2. For 1, we see that y is going to equal 5. And then when we go to -2, we see the answer is 2. And for -3, the answer is 5. I've gone ahead and I've plotted those points on the graph, and now I can connect the dots and create my parabola. Please note on the table that you can see symmetry within the table as well. So I've left it with my -1 and my +1 smack in the center. Now right out from there, if we look, we see 2's on the outside of the 1, on both sides of the 1. And following that, the next layer is 5's on the outside of the 2's. So that symmetry, that unfolding, also happens on the table itself. So at this point, you may want to try to pause the video, try this on your own. I have the steps written here, but I've also got my equation here. And so the equation is 2x squared minus 8x plus 6. Step 1, determine if it's going to open upward or downward. We've got a positive a value, it's a positive 2, so we know that it's going to open upward. Next, we're going to look for the axis of symmetry. So we have to start to get that memorized, where we know that it's -b over 2a. So when I'm trying to calculate my axis of symmetry, I'm going to look for my -b. So I'm going to place the negative there. Now I'm going to go get the b, and I'm going to do it in a different color because I want you to see that we've got a -8 for our b value. I'm going to place the 2 here, and then I'm going to get the a value, which is 2 in this case. So now I'm going to solve for my axis of symmetry. -8, a double negative, is going to be a positive. So we have a positive 8 over 2 times 2, which is 4. So my axis of symmetry is 2. I should then draw a line at x equals 2. Okay, so now that I have my axis of symmetry, I know that x equals 2 in my xy coordinate for my vertex. So I'm going to substitute it into the equation to get the y value so that I have the xy coordinate of my vertex. So we have 2x squared minus 8x plus 6. So that's our initial equation. Now we're going to substitute the value in. 2 times 2 to the power of 2 minus 8 times 2 plus 6. So we're going to follow order of operations and first do our exponents. So we have 2 times 4, because 2 to the power of 2 is 4, minus 8 times 2 plus 6. I'm going to go ahead and do my multiplication because my addition and subtraction are going to happen afterwards and there's no other operations happening with division and multiplication. So 2 times 4 is 8, and then negative 8 times 2 is negative 16 plus 6. 8 minus 16 is negative 8 plus 6 gives us a negative 2. So our vertex is 2, negative 2. Okay, so we've completed step 1, step 2, and step 3, and I've now completed step 4 as well. I've drawn my vertex and the axis of symmetry on the coordinate grid. So step 5 is going to have me choose 2 values greater and 2 values less than the axis of symmetry. So I'm going to go ahead and I'm going to write a table, but I'm going to do it towards the bottom. I'm going to do it horizontal this time. So I know that 2 and negative 2 are a coordinate pair on my parabola, on my graph. So now I'm going to look for 2 values that are greater than 2. So we're going to go with 3 and 4. And then we're going to choose 2 that are less than. So that would be 1 and 0. So now I've got my x values. Just like if I had a linear equation, I need to substitute those x values in to find the y value so I know my coordinate pair. Okay, so we're going to start with 0. We're going to substitute it in. We have 2, 0 to the power of 2, minus 8 times 0, plus 6. 0 to the power of 2 is 0. So we have 2 times 0 minus 8 times 0 plus 6. And 0 times anything is 0. So now we have 0 minus 0 plus 6. And so we know our value for 0 is 6. I'm just going to draw a line there to kind of separate my table a little bit better. Okay, so I'm going to plot that point at 0, 6. Now I'm going to substitute the 1 into the equation. So we have 2 times 1 to the power of 2 minus 8 times 1 plus 6. So our exponent, 1 to the power of 2 is 1. And then we just copy everything back down. Now we're going to do our multiplication. 2 times 1 is 2. 8 times 1 is 8. And now we do our subtraction and addition. 2 minus 8 is negative 6. Plus 6 is 0. So we can see that our next coordinate is 1, 0. Our next point that we want to solve for is where x is 3. So I'm going to substitute the 3 in. So 3 to the power of 2 is 9. And then we copy everything back down. 9 times 2 is 18, and negative 8 times 3 is negative 24. And then we have our positive 6. So 18 minus 24 is going to give us negative 6, and negative 6 plus 6 is 0. So we're starting to see that symmetry happening. The zeros are happening around the negative 2. Okay, we're doing our last value of x for this table, and that's 4. So 2 times 4 to the power of 2 minus 8 times 4 plus 6. So now if this goes right, we should get 6 as our solution. So we have 4 to the power of 2 is 16. And then we copy everything. So we show we're doing our order of operations. Now we're going to do multiplication. 2 times 16 is 32. And then 8 times 4 is 32. We kept our negative, and plus 6. So we can see that the 32 minus 32 is going to cancel out. We're going to have a positive 6. and we did show that symmetry. So I plotted all my points, and the last thing I need to do is connect the dots to create my parabola. Not the best drawing with my finger, but hey, it works. Moving on to the next problem, you can again start working on this one on your own if you'd like. So the problem that we're going to solve this time is y equals negative 2x squared plus 8x minus 5. When we look at this equation, we first want to determine, is it going to be a positive or a negative parabola? And based off the fact that our a value is a negative 2, it's going to be negative or a frowny face. So knowing that helps us when we graph to know which direction we should be going and if we're doing our graph correctly. Next, we want to do the axis of symmetry. So looking at the axis of symmetry, our formula is negative b over 2 times a. I'm going to go ahead and put the negative from this, and then I'm going to look for my b value, and my b value is a positive 8 this time, so we're just going to place an 8 there. Place my 2 down here in the denominator, and then I'm going to look for my a value. My a value is a negative 2, so this time I'm going to multiply times negative 2. I simplify, and I get negative 8 over negative 4, which equals 2. So our axis of symmetry is 2. So even though we had a different a value as far as our positive versus our negative in our previous problem, our axis of symmetry is the same, and that's okay, because just because the axis of symmetry is the same does not mean the graph will look the same. It just means that they had a symmetrical line at that point. The shape, the width, everything about the parabola could be completely different though. Okay, I went ahead and drew the axis of symmetry, and now I'm going to find the vertex. I know that the x value of that vertex is 2, so I'm going to substitute 2 into the equation that we have. I'm also going to go ahead, and this time I'm going to write my x in my table ahead of time. Since I already know that I'm going to have a 2 here, I'm going to place that here, and then I'm going to solve the equation with 2. So negative 2 times 2 to the power of 2 plus 8 times 2 minus 5. So we have negative 2 times 4 plus 8 times 2 minus 5. Now we're going to do our multiplication. We get a negative 8 plus 16 minus 5. And now subtraction and addition. So negative 8 plus 16 is a positive 8 minus 5 is 3. So you can see now our vertex is 2, 3, which is different than our vertex in our previous problem. And now I'm going to choose my greater than and less than values of my axis of symmetry for my x values. So my greater than, we're going to go with 2, 3, 4, and backwards we're going to go 2, 1, 0. Okay, so I've got my values there. Now I'm just going to substitute them into the equation as I have previously and solve. Okay, so I'm going to start out with the 1 for x, and so I've rewritten the equation. I'm going to go ahead and solve, and I'm going to find my solution. Okay, so I've gone ahead and plotted that point, and now I'm going to substitute 0 into the equation and solve for 0. And so we have negative 2, and 0 to the power of 0 is 0. And then this is 0 plus 0 minus 5, so we have a negative 5 over here. Next, we substituted 3 into the equation, and we solve. 3 to the power of 2 is 9. Multiplication, negative 2 times 9 is negative 18. Plus 24 minus 5. So here we're going to get a positive 6 minus 5, which gives us our 1. So we're seeing the symmetry. And lastly, we're going to solve for 4. So I have negative 2. 4 to the power of 2 is 16. And we rewrite the equation. Now we're going to multiply. We get negative 32 plus 32 minus 5. These cancel out, and we get negative 5 as our solution. And again, we have perfect symmetry. And lastly, we would connect our dots to create our parabola. This concludes this lesson. You can get some great practice off of Desmos if you want to use a utility that actually will plug in the information for you, and you can find the coordinates by using sliders and everything to see how things change.